This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 12. You've finished Week 2 Fluid Mechanics. 11 topics, every formula handbook indexed, every problem type worked. This video is about how to use it, where to spend your final study days, how to navigate the handbook at speed, the traps that repeat, and the time budget that gets you through fluids with margin. The priority matrix. 3 are very high yield: Bernoulli, Darcy-Weisbach with the Moody chart, and pump sizing. 4 more are high yield: fluid statics, minor losses, pump curves, and flow measurement. Those 7 cover roughly 70% of the fluids exam. The remaining 4, impulse momentum, drag, compressible flow, and fans, are medium yield. Study them only after you own the 7. One weekend before exam day, spend it on topics 02, 03, 05, 06, and 07. What changes from Week 1? Fluids is more diagram heavy. Every momentum or energy problem starts with a control volume sketch. Unit bilingualism matters more. The split is roughly 60-40 SI to IP, and specific weight gamma in IP is pound force per cubic foot, while in SI we use rho times G, the biggest unit trap. Most pills point to Section 3. The outliers are the compressible flow tables and fans, and the drag coefficient tables aren't in the handbook, the one place you bring an outside reference. Navigation. In your first 60 seconds of Session 1 before solving anything, bookmark about 12 sections. Hydrostatic pressure and forces on submerged surfaces, manometers, continuity, Bernoulli and extended energy, Reynolds number, Darcy-Weisbach, the Moody chart, pump characteristics and power, the affinity laws, Venturi and orifice meters, and the 2 outliers, the compressible flow tables and fans. The screen shows the exact section and page for each. Practice setting them until it takes under a minute. The 10-second rule. Open the handbook search bar and type one keyword: Bernoulli, Darcy, Reynolds, Moody, manometer, Venturi, orifice, affinity, NPSH, choked, isentropic, normal shock. If the formula doesn't surface in 10 seconds, skip, flag, and return in pass 2. Don't dig, don't scroll. Most students lose more fluids points to slow navigation than to physics. Make search a reflex. Handbook first, memory second. Don't memorize the friction factor or the function tables. Just know where they live. Trap Compendium, topics 1 through 4. Statics. Don't mix gauge and absolute pressure in one balance. Pressure decreases going up. Bernoulli. Run the 5-second check first. Incompressible, steady, inviscid, along a streamline. No work. If any is no, use the extended energy equation. Darcy-Weisbach. Darcy is 4 times fanning, and the Moody chart is the Darcy version. Minor losses. Don't mix the K-factor method and equivalent length on one fitting, and never forget the exit loss of 1 into a large reservoir. Trap Compendium, topics 5 through 8. Pump sizing. Shaft power is rho GQH over efficiency. The efficiency divider is mandatory, and a pump that meets head and flow can still cavitate if NPSH available is short. Pump curves. The operating point is the intersection of pump and system curves, not the pump curve alone. Affinity laws. Flow with speed, head with speed squared, power with speed cubed. Flow measurement. Keep the 1 minus beta to the 4th term, and use the right discharge coefficient, about 0.6 for an orifice, 0.98 for a Venturi. Momentum. Draw the control volume first, and Joukowsky uses the wave speed, not the flow speed. Trap Compendium, topics 9 through 11. Drag. The sphere drag coefficient isn't constant. A drag crisis near a Reynolds number of 3 times 10 to the 5th drops it by a factor of 4. Reference area is frontal for bluff bodies, planform for flat plates. Compressible flow. Above Mach 0.3, drop Bernoulli for the isentropic relations, and use absolute temperature in the speed of sound equation, never Celsius. The function tables are the most overlooked pages in the handbook. Fans. Distinguish total from static pressure, and fan affinity laws are identical to pump affinity laws. Time budget. 80 questions over 480 minutes, 6 minutes each. Fluids is roughly a quarter of the exam, so plan about 2 hours. First pass at 4.5 minutes. Solve the easy ones, skip and flag the long dig and trap-prone ones. Second pass, return to flagged at 6 to 8 minutes. Last 20 minutes, review flagged, but change one only with specific evidence of an error. Never leave blanks. Eliminate 2 and guess. Hard limit, over 8 minutes on one question, flag and move on. Per question rhythm, 5 beats. 1. Read the problem fully. 2. Sketch the control volume. Every fluids problem deserves it. 3. Build the variable table. Every quantity, value, and source. Empty cells expose what's missing. 4. Solve using the topic framework. Bernoulli, Darcy-Weisbach, extended energy, momentum. Don't improvise. 5. Sanity check in 20 seconds. Units stack. Reynolds in the expected regime. Friction factor plausible. Efficiency between 0 and 1. Mach below 1 unless the problem says supersonic. If any check fails, flag and return. 24-hour review. Night before, no new material. Skim the priority matrix. Re-watch the trap slides for topics 3, 5, and 7 if rusty. Lay out your ID NCEES approved calculator, layered clothing, snack, and water. 8 hours of sleep, 2 alarms. Morning of, breakfast with protein and complex carbs, no caffeine shock. 10-minute handbook drill, search 5 random keywords, practice the 10-second rule. Arrive 30 minutes early. During the break, protein and water, walk, don't cram. Session 2 is a new exam. Week 2 recap. 7 things you now own. The 4-beat structure. Concept, setup, solve, traps. The control volume sketch as your first move. The variable table framework. Your handbook bookmarks. Keyword cues to pick the right framework. Trap categories across all 11 topics. And the time budget. 6 minutes per question, never more than 8. Next, week 3, heat transfer. Same structure, same framework, new physics. Conduction, convection, radiation, exchangers, fins, transient. Thanks for completing week 2. If it helped, please subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.